Welcome to clickmyproject.com. Our product title is single phase to three phase converters with two parallel single phase rectifiers and reduced switch count. Let us see a board abstract of our product. In this implementation consists two single phase to three phase conversion systems for a three phase load applications. The load is connected to a single phase grid through an AC to DC, DC to AC single phase to three phase converter. The single phase rectifier is composed of two parallel single phase half bridge rectifiers. The main objective of this design is based on number of switching devices is reduced. In the case of full bridge rectifier and three leg inverter systems. In addition, the source voltage sensor is eliminated with a state observer which control the deviation between the model current and the system current to be zero. A simple scalar voltage modulation method is used for a two-leg inverter, and a new technique to eliminate the effect of the DC link voltage ripples on the inverter output current is proposed in this implementation. Although the converter topology itself is of lower cost than the conventional one, it retains the same function such as sinusoidal input current, unity power factor, DC link voltage control, bidirectional power flow, and variable voltage and variable frequency output voltage. Proposed design permit to improve the harmonic distortion. In addition, the P5L converter can reduce the converter power losses. P5L is nothing but proposed 5-leg converter. Next we see about flow diagram of our product. In this proposed implementation we done two kind of implementation. First one 5-leg AC to DC to AC converter. In this process first block is a single phase AC source. That AC source is fed into the rectifier circuit through a passive elements such as capacitor, inductors and so on. After that rectifier is the process of AC to DC conversion. After that the output of the rectified DC output is fed to the three-leg inverter circuit through a DC link capacitors. In the three-leg inverter is used to convert DC to AC. Here we using 6 switches, each leg having 2 switches. So this is called three-leg inverter, and that output is fed into the three-phase motor. So corresponding output will be taken in the three-phase output in the inverter side. Next one is the 4-leg AC to DC to AC conversion. In this implementation the process is also similar to 5-leg AC to DC to AC converter, but in the inverter side only the construction will be differ. Initially the input AC source is fed into the rectifier through a passive elements. After that rectifier rectified the AC to DC output, that DC output is fed into 2-leg inverter through the DC link capacitor. In the 2-leg inverter is nothing but that having 4 switches and each leg having 2 switches. Switches means IGBT or MOSFET is fed into the 3-phase motor. 2 phases is getting in the corresponding 2 legs and 1 phase is getting in the TC link capacitor midpoint. So the output will be getting from the output of the 3-phase inverter side. The voltage and current is taken, and also the output of the motor parameters will be taken in the 3-phase motor output side, and the feedback loop is getting from the output side, and that is fed into the controller side, and the controller is used to generate the pulses, and that is fed into the rectifier and inverter side. Next we see about running process of our product. In this proposed implementation is done in MATLAB simulating environment. First open the MATLAB window and create a new model file. After creating the new model file, we arrange the elements as per the circuit diagram. After arranging that, we click the run icon. After clicking that, the corresponding output will be displayed in the corresponding scopes. In this proposed implementation, 2 kind of output will be displayed, and one is the 5 lag AC to DC to AC converter design, and next one is the 4 lag AC to DC to AC conversion. First one is the input voltage waveform. This is the AC waveform, so like this. And next one is the input current waveform, and next one is the DC link capacitor voltage waveform. This is getting from the output of the rectifier side, and this is capacitor 1 output voltage waveform, and this is the capacitor 2 output voltage waveform, and this is the inverter output voltage waveform for bar phases in 5 lag inverter side. And next one is the 3-phase voltage waveform is getting from the inverter output, and next one is the inverter output current waveform, and next one is the each basis inverter current waveforms, and next one is the motor, rotor and stator current waveforms is connected through the inverter output side, and next one is the stator voltage, electromagnetic torque and rotor angle and rotor current values is given here, and also the speed is shown in the waveform. And next one is the 4 lag AC to DC to AC converter output current waveform, and next one is the voltage waveform of 4 lag AC to DC to AC converter, and next one is the corresponding pulses is given to the corresponding rectifier and inverter is connected in the two kind of designs, and next one is the space vector pulse with modulations output waveform. So the overall efficiency will be increased due to the reducing of the harmonics. So overall design will be implemented in the corresponding designs. Thank you for watching this video.